Miles above the surface of the Earth, a shuttle astronaut will attempt a delicate repair procedure. Months of engineering effort and thousands of dollars have gone into the preparation for this moment.
Problem here. I'm about 3 inches shy of being able to reach the outboard bolt with this wrench.
I don't understand. When we tested this before, you had room to spare.
We either need a different wrench or an astronaut with longer arms.
Well, come on in. Let's see if we can work it out.
Fortunately, this repair procedure is being developed and tested on Earth before it ever goes into space. The design team has wisely taken the opportunity to simulate it under space-like conditions using the neutral buoyancy simulator at NASA's Marshall Space Flight Center. The Marshall Space Flight Center's comprehensive aerospace research and development complex occupies over 1,800 acres at Huntsville, Alabama. While the center manages various space science programs and propulsion systems, it also is a test and evaluation center for a wide range of space-related hardware, and has developed some unique facilities for simulating the space environment. One of these facilities is the Neutral Buoyancy Simulator. With a volume of nearly 5 million liters, the NBS tank at the Marshall Space Flight Center is the largest facility of its kind in the world. In addition to providing a close approximation of the zero-gravity conditions of space, or even a slight negative buoyancy to simulate the gravity of the Moon or Mars. The tank's 12-meter depth and 23-meter diameter can accommodate large space structures, such as a full-scale space shuttle payload bay, complete with payload doors, as well as a full-scale working mock-up of the space shuttle's remote manipulator system. One of the primary goals of any extravehicular activity, or EVA, in space is the efficient use of manpower. While computer modeling can help to minimize the time required, there is no substitute for testing the procedures under actual operating conditions, using real people. With three-dimensional movement in any orientation. From design concept through verification, the Neutral Buoyancy Simulator affords designers and engineers the time and opportunity to do a thorough job on development by providing them with practical, hands-on space experience at a relatively low cost. As a government-operated facility, the Neutral Buoyancy Simulator is available to NASA programs, government agencies, universities, and NASA's international partners on a request basis. Users are charged a nominal fee based on the requirements of the test and time in the water. Once a user's request is approved, the Systems Analysis and Integration Laboratory will assign a test engineer from the Neutral Buoyancy Simulator to act as liaison and coordinate the user's test planning.
Where's the RMS in relation to all this?
Right in this southwestern corner, if you will.
This NBS test engineer will guide the user through the entire process, becoming thoroughly familiar with the test needs and equipment, and will advise the user as to the size and weight requirements for equipment to be tested. However, pieces of equipment that in their assembled state are larger or heavier than allowed by these requirements may be brought in smaller or lighter sections and then assembled underwater. For pieces of equipment that are too large or heavy to be hoisted from the high bay area, a construction crane may be used to lift the equipment from outside of the building through a removable section of roof. The neutral buoyancy simulator is large enough to accommodate the Space Station Freedom's modules in their assembled state. The NBS test engineer inspects all users' equipment prior to installation to assure that all the equipment is present. There are no sharp or jagged edges which may cause injury, that the equipment is properly secured, and that the weight restraints are not exceeded. Once lowered into the water, the equipment must be neutralized so as to simulate its being in a zero-gravity environment. If the equipment is lighter than water, weights are added for neutralization to increase its negative buoyancy. Equipment that is heavier than water is neutralized by the addition of floats, such as sealed plastic tubing and rigid plastic foam, to increase its positive buoyancy. In addition to being neutralized so that it neither sinks nor floats, equipment must also be rotationally balanced. A variety of high-fidelity mock-ups of actual extravehicular activity hand tools and equipment are available. These items are the exact shape and size of the actual flight tools used by the astronauts. To make more efficient use of the test time, a rehearsal is conducted before an actual test is run. This rehearsal, with all the principles in scuba gear, assures that simulated EVA procedures can be achieved, that all repairs or installations on equipment can be accomplished, and that all personnel are familiar with the test procedure. Safety is of primary importance at NASA. Consequently, all user personnel who will be diving must have a current scuba certification, CPR certificate, first aid certificate, and a medical examination within the 6 months prior to the dive. Non-NASA personnel must also have a letter of clearance from the Marshall Space Flight Center management. A checkout dive for all personnel who will be diving, conducted by a certified scuba instructor, includes a briefing on the tools and hardware, a walkthrough of the facility and safety review, and is designed to identify an individual's strengths and weaknesses with regard to the basic knowledge and skills required of a scuba diver. All divers are also given a pre-dive checkup by emergency medical technicians prior to each dive and are required to complete a physical questionnaire attesting to their general health on that day. On the day of the actual test, the test conductor, who is a representative from the user organization, chairs a briefing for all personnel involved. The test procedure is reviewed, as are the diver assignments and the location for the placement of tools and equipment. After the briefing, the personnel who will be performing the test, acting as astronauts, are suited up. These are the actual spacesuits worn by the astronauts. The NBS facility has the capability to conduct tests with 2 suited subjects. Each suit is specifically assembled to each test subject's physical requirements. The suit lab can fit 95% of the population size range with a 1-day turnaround to assemble the suit. With 3 basic sizes of hard upper torsos, medium, large, and extra large. The remainder of the suit is hand assembled from combining various length standard components and inserts to arrive at the required size. To assure the safety of the personnel who will be wearing the suit, each suit is checked visually and is pressurized to verify structural integrity and certify the absence of leaks.
Okay, that's 6.6. All right.
The suit is then checked mechanically for torques, ease of the rotational components of the arms and waist, and security of the locking systems. Once in the water, each suited subject is accompanied by 2 safety divers in scuba gear. In addition to adding or taking away weights from the subject's suit so that they are neutrally buoyant, they are moved into position for the test. The safety divers remain with the subject throughout the test and are responsible for their safety. The primary function of one of the safety divers is to shepherd the suited subject's umbilical, which contains the breathing air, communications, and suit coolant, keeping it clear of entanglements. The other safety diver keeps watch over the suited subject, looking for any possible dangers. Both safety divers are continually conscious of maintaining a clear path out of the water for their suited test subject. Other divers also assist the suited subjects during the test. Utility divers, in addition to being responsible for the initial installation of the test equipment, are responsible for the transfer of the test equipment, fetching of tools for the suited subjects, and adjustments of foot restraints. User personnel who need to see firsthand how the test procedure is accomplished are permitted in the tank as observer divers. To further oversee the safety of all the divers and suited subjects during the test procedure, 2 water safety divers keep a continual presence just below the water's surface, acting as lifeguards. Although its use has never been required during an NBS test, the facility is equipped with a hyperbaric chamber, which could be used in the case of a diver's decompression sickness. A physician qualified in hyperbaric medicine is always on call. During all tests, 4 crew members trained in the use of the chamber are also present, 2 of whom are stationed at the top of the simulator tank, and 2 in the NBS building on standby. Also, a lightning detection system displays any lightning strikes. If lightning comes within 10 miles of the NBS facility, the tank is evacuated. Once all participants are in the water and in place for the start of the test, the NBS test director turns over control of the test to the user's test conductor. The test director will then monitor the test procedure as an interested observer, intervening only should an emergency arise. From the control room, the test conductor directs the test procedure step by step. The conversation between the test conductor and the suited subjects is piped into the water tank through underwater speakers and can be heard by all scuba diver personnel. In order to provide the user with an accurate engineering analysis tool, as well as an historical record of the test, the NBS facility has complete state-of-the-art video recording capability. The test conductor's console contains 6 video monitors, so that the conductor can see what the various video cameras see. In addition to the topside camera, 3 underwater cameras are mounted on the side of the tank, and a swim camera is operated by a scuba diver. The test conductor can direct the NBS instrumentation technicians to focus any camera on any subject. Since its opening, Marshall Space Flight Center's Neutral Buoyancy Simulator has helped designers and engineers develop effective designs and repair procedures for many of NASA's space programs. From real-time support of the Skylab mission in 1973 to hardware tests for space shuttle missions, to testing repair procedures for the Hubble Space Telescope, to testing design concepts for the space station. The Neutral Buoyancy Simulator has and will continue to provide NASA, its international space partners, and all other users with the confidence that hardware and repair procedures which work in neutral buoyancy simulations will in fact work in space.